Today we're going to be solving question 47 of the 2021 Junior Mathematics Olympiad first round. The question goes like this. 6 friends want to play enough chess games to be sure that everyone plays with everyone else. How many games will they have to play? Okay, so before we talk about 6 friends, let's assume that there were just 2 friends. So let's say we have person A and B, and they want to play in such a way that every one of them plays with everyone else. So how many games will they play? They'll have to play just one game, which is the game A versus B. That's where A plays against B. So when you have 2 people, it's just one game you have to play. What about when you have 3 people? Let's say persons A, B, and C. But this one game that they'll have to play is A versus B. That's where the first plays the second. And then also the game A versus C. And finally B versus C. So we're going to have 3 games for this case. If we have persons A, B, C, and D, so let's say we have A, B, C, D, it's going to be, the games are going to have to play will be A versus B, A versus C, and A versus D. So person A will play with everyone else, and then person B will play with person C and D, since C and D here, and then person C will play against person D. So when you have 4 people, they will have to play just 6 games. When you have 3 people, they'll have to play 3 games. And when you have 2 people, they'll have to play just 1 game. So now they're telling us, what if you have 6 people? How many games would they have to play? So we have peoples A, B, C, D, E, and F. Right. Okay, so similar to what we have here, let's say we're trying to build all these pairs where you have some person versus some other person. How many such pairs would there be? So this is what we're going to try to count now. Okay, so let's say we're trying to form these pairs, right? That's a pair of one person versus another. We'll have 6 choices for who to put as the first person, right? Since we can pick any of the 6 people to be the first player, so we'll have 6 choices for that. And then for the second person, we're going to have 5 choices, since that the second person has to be a different person from the first person. So like in total you get 30. So there are 30 possible pairs of one person versus another. But then notice that in these pairs they're going to be duplicates. Why? Because while generating these 30 pairs, we'll have maybe A versus B somewhere, and we'll have A versus C, and let's say C versus D. But at the same time, while generating these pairs, we'll also have B versus A, C versus A, and D versus C. And if you look closely here, the game where we have A versus B is the same as the game where we have B versus A. And the one where you have A and C is same as when you have C and A. And the one where you have C and D is same as D and C. So to account for these duplicates that are going to occur, you're going to divide by 2, since they are just 2 permutations, right? A versus B is same as B versus A. So to account for that, you're going to divide this by 2 now. So the number of games they'll have to play is going to be 30 divided by 2, which is 15. A different way of solving this question will just be, since we're trying to pick 2 people out of 6 and the order of the people doesn't matter, that'll just be 6 choose 2 or 6 combination 2, which is 6 factorial divided by 6 factorial divided by 4 factorial times 2 factorial, which will be 6 times 5 times 4 times 3 times 2 times 1, which is same as 4 factorial, divided by 4 factorial times 2 factorial. So we have factorial here. And then these 4 factorials cancel each other, and you'll be left with 6 times 5 over 2 factorial. That's 6 times 5 over 2. And you still have 15 here. So this is how to go about solving this question. And the correct answer here is option D.